Welcome to Shree Learning Academy. Our today's topic is weak implementations. So let's get started. Introduction. Cryptography is a critical aspect of modern information security, providing a bulwark against unauthorized access to sensitive data. However, its effectiveness is often undermined not by flaws in the cryptographic algorithms themselves, but rather through weak implementations. The strength of cryptographic algorithms. At the heart of any cryptography system is the algorithm, a complex mathematical process used to encrypt and decrypt data. These algorithms are designed to withstand focused attacks and undergo meticulous examination by cryptography experts around the world. A good example is the Advanced Encryption Standard, AES, which is used worldwide and has been subjected to thorough scrutiny without any significant weaknesses found. However, no matter how sturdy an algorithm is, it is only as secure as its implementation in real-world software applications. In this context, implementation refers to the process by which a programmer incorporates the algorithm into a software product. The pitfall of implementation errors. Cryptography systems fail primarily due to poor implementation. The root cause is often software development errors, rather than weaknesses in the algorithms themselves. For instance, a programmer might inadvertently introduce a bug into the software that bypasses a security check or leaks sensitive information. Consider a scenario where software uses an impeccable algorithm like AES, but the implementation has a bug that causes it to use the same encryption key every time. No matter how robust AES is, using the same key for every encryption creates a significant vulnerability that could be exploited by a determined attacker. The challenges of proper randomization. A key part of implementing a secure cryptographic system is the generation of unpredictable encryption keys. This is typically done using randomization functions, which generate a seemingly random string of numbers. However, proper implementation of these functions can be very challenging. Many programmers, particularly those who are not well versed in the nuances of cryptography, may rely on simple randomization functions provided by the programming language or execution environment. While these may seem random to a human observer, they are often predictable to a computer. In many cases, these functions are based on a seed value, such as the current time, which an attacker could potentially guess or discover. An example can be seen in the Debian OpenSSL vulnerability discovered in 2008. Here, due to an error in coding, the random number generator was only producing a small fraction of possible encryption keys. This made it much easier for attackers to guess the keys and decrypt sensitive data. Common weak implementation practices. Aside from poor randomization, there are several other common weak practices in cryptography implementation that can lead to system failures. Key reuse. Key reuse is a common mistake, particularly with symmetric encryption where the same key is used to both encrypt and decrypt data. While it may be easier to simply use one key for all data, this approach severely weakens the security of the system. If an attacker manages to discover the key, they can decrypt all the data it was used for. Sequential or pattern keys. Using keys in sequential order or based on a predictable pattern is also a weak practice. Like using simple randomization functions, this may seem random to a human observer, but to a computer, it's a pattern that can be exploited. Insecure key storage and distribution. Even if keys are generated and used properly, they must also be stored and distributed securely. A common mistake is storing keys in an insecure location, such as a publicly accessible database or a plain text file. This is equivalent to locking your house but leaving the key under the doormat. Resolutions to weak implementations. Addressing these challenges requires a combination of secure coding practices, expert advice, and thorough code review. Adopting secure coding practices. Developers should adhere to secure coding practices, like those outlined in the OWASP Open Web Application Security Project guides. This includes adhering to the principle of least privilege, validating input, and protecting data in transit and at rest. Moreover, in terms of cryptography, it's important to use tested libraries instead of creating your own. Libraries like OpenSSL, Knuckle, or Libcdium have been scrutinized by experts and found to be reliable. Implementing cryptographic algorithms from scratch opens the door for errors and vulnerabilities. Seeking advice from expert programmers and cryptography SMEs. Security is a specialized field, and cryptographic security even more so. A generalist programmer may not be familiar with the intricacies of secure randomization or the risks of key reuse. By seeking advice from cryptography subject matter experts, SMEs, teams can avoid common pitfalls and ensure their systems are secure. This advice can be sought in many forms: direct consultation, training sessions, or even through reading and following expert guidance available in books or online resources. The key point is not to assume one knows everything about cryptography but to seek knowledge from those more experienced. Thorough code review and analysis. Code review is a crucial part of the software development process. Having another set of eyes on the code can often spot errors that the original programmer missed. Code reviews should be comprehensive, covering not just functional requirements but also security aspects. Additionally, dynamic and static code analysis tools can help identify potential security issues, including weak cryptographic implementations. These tools, when used properly, can be an invaluable addition to the code review process. Conclusion. In summary, while the cryptographic algorithms we use today are generally very strong, the way they are implemented can often introduce vulnerabilities. Implementation errors, poor randomization, key reuse, sequential or patterned keys, and insecure key storage and distribution are just some of the issues that can lead to system failures. To combat these, software developers need to adopt secure coding practices, seek expert advice, and perform thorough code review and analysis. With these measures in place, the robustness of cryptographic algorithms can be fully realized, significantly enhancing the security of our software systems. Thank you so much for watching this video. Do check out the written explanation on our website and don't forget to take this quiz based on this video. The links are in the description box below. Subscribe to our channel to watch more interesting videos. If you have any doubts, do let us know in the comment section and we will try our best to solve them for you. For private coaching, do contact us by visiting shreelearningacademy.com or on WhatsApp. See you in the next one.